Greetings, everyone, and welcome in to my channel. I am Professor L, and a reminder, this is a math stream, live stream for math help. So if you do have a question or a math problem you'd like to see worked out, you can post it in the chat. And today I am going to be continuing my discussion about the graphs of the trigonomeric functions, and I am going to be sketching the graph of the arctangent function. So yeah, if you are interested on what the behavior of this graph looks like, and you're wanting to get a more general understanding of the domain and range of the tangent and the arctangent function, then you're welcome to tune in. And feel free to ask questions if you have them. All right, so I'm just going to get into it. And recall from yesterday, before we erase this, we graphed the cosine function by plotting a set of ordered pairs in their domain and their range. And then we switched the domain and range and graphed the arc cosine function here. And if you notice that the arc cosine and the cosine function have this unique relationship where the domain and the range has been reversed, swapped out. And the graph of cosine was, we restricted the domain from 0 to pi, and got this lovely graph. And so we're going to do a very similar process for the tangent function. And so we'll just get into it. All right, let's see how it goes. Right, so the tangent function is very useful in solving problems in mathematics because of its unique relationship to sine and cosine. Sometimes when you only know the side lengths and you don't have any information on, if you have a limited amount of information, the tangent function can be of a lot of help. So we'll title this the graph of arc tangent. The tangent's very useful in solving problems in upper level math and trigonometry. Having a general idea of behavior of the graph is very important, and knowing your restrictions in your domain and range. Tangent is slightly different though, so we'll start out with y equals tangent x. And recall that the tangent function, that tan theta equals sine theta over cosine theta. All right. And we'll start by building a table. We need a set of ordered pairs to plot points. So we'll start with, and recall we graphed tangent last week. And so what we're going to have to do is we are going to have to restrict the domain of the tangent function, similar to how we did for sine and cosine. Tangent, because of the graph of tangent and the way the symmetry about the origin, it has to do with the even odd functions. But tangent has to be restricted between negative pi over 2 and positive pi over 2. And so we'll just get a real quick sketch of behavior of tangent. And recall, tangent has these weird vertical lines called asymptotes. And these asymptotes appear in intervals every pi interval. And there's an asymptote at negative pi over 2 and positive pi over 2. So let me go ahead and draw. I'm going to need a little bit bigger unit circle. And really, I only need to go, I'm going from negative 2 pi down here, or negative pi over 2 rather, and positive pi over 2. And recall the reason why that is because this fact right here, because tangent is behaves more like a rational function, there's going to be values in the domain that, in the denominator that force a 0. So there are places on the cosine graph where the value is 0. Anytime that happens, you're going to get an undefined value. And we found that those values are appearing at negative pi over 2. Getting ahead of myself. But we'll go ahead and put those in there, and pi over 2, right? And so what we're going to do is go ahead and put these values in here because this is what I need. So we've got this part of our unit circle we're going from pi to negative pi over 2. We got 0, and we're going to figure out all of these angles in between. And I think we need about 5 clear points. So I think we'll start with that's negative pi over 4 and pi over 4 here. So that'll give me 1. Really, pi over 2 and negative pi over 2 are the asymptotes. So they're going to bound the graph, but we'll go ahead and count those. So we'll have 3 clean points. We'll have a value at pi over 4, 0, and then negative pi over 4. And recall these ordered pairs on this unit circle here. This is 1, 0 at 0 degrees. This one is at 0, 1. And this one was at 0, negative 1. And let's see here. So we've got the cosine and the sine. And this one's the cosine and the sine. So at pi over 2, when we do negative 1 divided by 0, we're going to get undefined. Writing things backwards today. So we'll have an undefined here. And then we're also going to have, this one's going to be sine over cosine. So this is 1 divided by 0. So this is also going to be undefined. Here, we'll write those over here. All right. So recall this trig function here is taking an angle into its domain, and we're calculating the value. So we'll just go from negative pi over 2, negative pi over 4. We'll go 0, pi over 4, and positive pi over 2. And again, we're listing these from least to greatest, from the leftmost value all the way to the rightmost value. And we're just going to get a general behavior so that we can see the differences between those two graphs. This will also help us sketch the graph of the arctangent pretty easy too. So we already know that we figured out when we plugged in tangent of negative pi over 2, and we evaluated that, and we found that that was sine over cosine, negative 1 over 0, which is undefined. Okay. So we're going to say undefined here. And then we're going to plug in negative pi over 4 into tangent. Tangent of negative pi over 4. And recall right here this value. And I happen to have that memorized. That is going to be positive radical 2 over 2, comma, negative radical 2 over 2. That is because in the fourth quadrant, you have your x values, your x component is going to be positive, and your y component is going to be negative. So we've got the tangent of pi over 4 is sine. So what it is it's sine over cosine. So you're doing negative radical 2 over 2 divided by positive radical 2 over 2. And doing all this math, you figure out that, well, when you have a division and you're dividing fractions, what you're doing is you're inverting that second, whatever's in your denominator, and multiplying. So what that leads to is negative radical 2 over 2 times 2 over radical 2. And you end up with negative 1 when you do the math and you simplify. So we'll say right here at negative pi over 4, we're at negative 1. Okay. And then we've got 0, the tangent of 0, right here. So we'll put this in here. I'm going to fit one more down here. Tangent of 0 degrees is sine over cosine. So that's 0 divided by 1 now. And that's just 0. Okay, so we have 0, 0 on there. And then pi over 4 is going to be similar to this, only it's not a negative because it's in the first quadrant. And so that's just going to be a positive 1. And then pi over 2 back up here, we're undefined again. Up here. Okay. So let's have this undefined. And I got ahead of myself and went ahead and put those asymptotes in there for negative pi over 2 and pi over 2, but that's what I would do next. I would go ahead and so that I can sketch the behavior of the graph. And then I'm going to go ahead and drop this point in right here. Negative pi over 4. And put this one in here, positive pi over 4. So I can make this a little bit bigger. And then get a little bit further down. Recall the domain and the range of the original tangent function. So before I sketch this in here, well, I guess I can wait till afterwards. What we're doing is we're going from positive 1 to negative 1. Looks like. Okay. So go ahead and sketch these points. So this is our asymptotes, and then we've got negative pi over 4 is at negative 1. And then we've got a point at 0, 0. And then we've got pi over 4 is positive 1 up here. So we've got these 3 points that's giving us a general behavior of our tangent function. Let's see if I can just draw it. Oh, I was supposed to dash it. Let me see if I can dash it real quick. I wanted to dash it because I'm trying to draw the arc tangent and get an idea Dash this one I caught at that time. Okay. And then we're going to talk a minute about the domain and range. All right, so recall, we're restricting the domain. So we're going to say the domain, and we're not going to use brackets. We're going to use parentheses this time because we're not going to be able to include, we're restricting the domain between the intervals negative pi over 2 and pi over 2. And since these are asymptotes, they're not actual points on the graph, then we're not going to include them in our graph, if that makes sense. So we've got this doodled and messed it up. Okay. And then we've got just continues. So we're going to say negative pi over 2, comma pi over 2. And the range of tangent, okay, has always been negative infinity to positive infinity. And then the domain looked funny, and I had to write it using set notation, if you recall, because of these asymptotes that are appearing every pi value. All right, so we have domain and range, and this is very important because when we're going to start talking about arc, cosine, arc tangent, we're going to have to swap these out. And so because tangent has a unique graph, it's different than the sine and the cosine graph because the range of the sine and cosine was bounded between 1 and negative 1. And for tangent, the range is infinity. So whenever you go to plot the arc tangent function and you swap out those domains and ranges, the domain becomes infinity. So let's see. I'm going to erase some of this. And because I'll need that space down there in just a second. I'm going to stop that graph about right there. Try to stay organized. All right, so arc tangent now. I'm going to go ahead and put it here. So we've got, this was tangent. And we're going to put arc tangent over here. And we have y equals tangent. So we'll abbreviate that tan and get a suntan. And we're going to raise it to the negative 1 power for our inverse notation. And that's of x. And I think we'll have enough room to, if we put our table right here, and I write kind of small. So we're first going to talk about the domain and the range of arctangent. And we're going to start by writing the domain. And I'm not making a mistake. I'm actually just swapping them out. So the domain of arctangent will take any value. And this is very handy in mathematics, being able to take any value into your domain of a function, and where if you were dealing with the same values, you could combine sine and cosine and use the tangent function. It becomes very, very useful. So we've got the range is going to be negative, and we're not going to include those values again. We're going to leave it parentheses. because of those asymptotes that appear. And that's pi over 2. All right. So what arctangent is doing is it's taking a side length ratio into its domain, and it's going to return angles. Okay. So what we're going to do is we're going to begin by evaluating arctangent. So we'll say y equals tan inverse, and we're going to pull up that first value. We'll go ahead and pick values for the domain. And we're going to use the values here. All right. And we're going to say, so we're going to plug in, let's see, how does that work? How do we swap those out? Let me think for a minute. Let's see, I know that pi over 2 I'm going to have to look at this afterwards. So it's undefined at negative pi over 2. Zero pi over 4 and pi over 2. Oh, let's increase this one up just a little bit. Pi over 4 and pi over 2. And we know it's undefined here. So how would we find that algebraically? All right, so I'll try not to get hung up on that detail. I'll have to think about that later. This is very good for me because it's forcing me to think about the math and all the details. And so I'm just going to go with it. All right, so I'm going to go ahead and say inverse tangent of -1. We'll start there. Inverse tangent of -1. And what's that function's asking is when is the tangent function equal to -1? So we'll go up here to our unit circle and find when our tangent function will be -1. It's over here at pi over 4, negative pi over 4. So we've got that value. -1, 0, and 1. So then when is tangent 0? It's at 0 degrees. And when is, so this one would be negative pi over 4. And then y equals tangent of 0. And that's 0. Oops. Inverse tangent. I guess I have my head in the clouds today. It's probably every day, but all right. So we have y equals inverse tangent. Just so you can see what it's doing, what we're actually doing is evaluating that function and plugging into its domain. Tangent inverse. And we're going to do +1. When is tangent +1? And we're looking up here. I didn't put it in here, but it's radical 2 over 2, comma, radical 2 over 2. So that is positive pi over 4. So we have our set of values. What we're going to do is go ahead and put in the values in my domain and range for my arctangent so that I can sketch them both on the same same graph. We'll get to see some symmetry here, see what's going on. So let's see, I need for my x value 1, and I already figured out that 1 is existing between pi over 4 and pi over 2, so we'll put 1 and negative 1 in here. And then I want to put, for my range, I want to fit in here. So we've got pi over 4 and pi over 2. And then this one would be pi over 4. And it's not perfect. It's fine. I'm not going to spend an hour trying to get this exact because it's a rough sketch, just like what it sounds. Negative pi over 4 and negative pi over 2. All right, very good. Maybe I should use different colors. Oh, that's next level. What I want to do after I finish with the arctangent function, maybe tomorrow or the next day, I want to start talking about the reciprocal trig functions. And so whenever I sketch the graph, maybe I'll try to get some colors out because the reciprocal functions are pretty interesting too. Okay. What I'm going to do now is I'm going to go ahead and start plotting the graph of the arctangent function. First, just getting these undefined values here and putting the asymptotes in here. So we've got one here. And we've got one right here. These horizontal asymptotes are going to bind the graph of the arctangent function. All right, and so now I'm just going to plot -1, negative pi over 4. So -1, negative pi over 4 is about right here. And we've got 0, 0, this point in common. And we've got 1, pi over 4. 1, pi over 4 is here. And so I'm going to go ahead and sketch this one. And it looks like, I think this is what it's doing. And this one has the domain goes to negative infinity to positive infinity. So it's approaching this asymptote at pi over 2, negative pi over 2, but it goes out to infinity both directions. It still has that symmetry again, but it's not restricted, which makes it very useful in solving problems in math. But you can see it still has that symmetry along the identity function line right here. And I'm probably not sketch it in there because there's so much going on, but just hold that up so you can visually see it. And then that's one of the ways that I know that I've sketched the inverse correctly, is just visually checking and seeing if there's a perfect symmetry along that identity function line, the y equals x. But more importantly, playing around with these graphs, getting a good visual image of what this function is doing will help later on when we're playing around and having to use the function to make calculations and solving bigger problems. So let's see how we did. Exactly 30 minutes. And so that's pretty good. Go ahead and square this off here. And this one here, so I can see it later before I erase. Yeah, so here is the graph. And I'll probably go ahead and stop there just because I realize that it's really hard to talk for a whole hour about something and hold attention. So I get that. So I really am okay. What am I trying to say? Yeah, we'll go ahead and stop there. That was a good, we'll be finished with the arc, we'll be finished with the inverse trig functions. I don't know why I'm getting tongue-tied. All right, well, I really appreciate you watching, and I hope that this was helpful in some way. I will continue to work on trying to be more concise, and I feel like the more I get used to presenting in this format, the easier it'll be. But I'll be back here regardless tomorrow between 6 and 7 p.m. And so if anybody needs help with their math, or they want to come and hang out and do math with me, that would be awesome. Again, thank you so much for watching, and I will be back tomorrow.